Any questions? Okay, if we go on to part B, here we got 20 employees of a large company are randomly selected to determine whether the proportion of company employees who are left-handed exceeds the national proportion of 10% who are left-handed. The hypotheses are that P is equal to 0.1 versus the alternative that P is greater than 0.1. So, first of all, is this a representative sample? In order to determine that, what's the first thing we have to decide? What is the target population here? What are they trying to make an inference about? What? Company employees. They're trying to make an inference about the employees of this one large company. Yes.
They're trying to take analysis of left-handed employees, and they're targeting all employees, so it wouldn't be appropriate.
In this case, they're targeting not all employees, but all employees of this company. And they're looking for the number that are left-handed. But if they aren't limiting their questions to just those who are left-handed, are they? If they were looking at just asking about left-handed people, then yes, that would be a limited population, so it would be something that would be not representative. But in this case, what it says is that they have a randomly selected group from this company. There isn't anything that says that they've taken that random selection and put anything on top of that. So it's randomly selected amongst all employees of the company. So in that case, we have a random sample, which is probably representative of the employees of the company. The target population is the employees of that company. So that says that the condition number 2 is met, right? This is probably a representative sample. So, condition number 3 is sample size. So if we look at this one, N is again 20, right? P0 is 0.1. The sample size is the same as it was in the first case. Should that be a big enough sample size? Well, it's not. We need 20 times 0.1 and 20 times 0.9. So this is equal to 2. This one is equal to 18. So that right there says that the sample size is actually nowhere near large enough. It's not even close. And that's because we're working with this small proportion. Effectively, what's happening is that we need normality, or that bell-shaped curve, to occur. And when you're near the center, like this, you've got a lot of room for that bell-shaped curve to spread out and be nice and symmetric. So a small sample that's spread out quite a bit has plenty of room to work. But when you get up near that edges, when you get near the edge at either 1 or 0, what happens is that you have to have a larger sample so that the bell gets very small, and so they'll fit into the area between that P0 and either 1 or 0, whichever end it's on. And that's essentially what this is doing here, is determining whether it is large enough to be able to fit in that small space. Okay? But we don't have to worry too much about that in this class. The main thing is follow the procedures. It says that it's too small. How big must it be in order for this to work? Sample size of 20 isn't big enough. How big does it have to be? Yeah. For P0 of 0.1, we need a sample size of at least 100 in order to get just the bare minimum for getting approximately bell-shaped curves. Okay. How about C? A company employs 500 stockbrokers. They're all surveyed to find out whether a majority believes the market will go up in the next year. We've got a P equal to 0.5, P greater than 0.5 for our hypotheses. What do you guys think about that? What's the target population here?
All the employees. Or all the stockbrokers. Yeah.
They're trying to find out whether a majority of the stockbrokers at this company believe the market will go up in the next year.
Is it
I don't know, this is kind of more of a question than answer, but would it be not representative because it's only one company, even though everyone's surveyed out of that company? That's not really giving an accurate picture of the way that the stock market is going to react or whatever in the next year.
Okay, what they're really looking for is not how the stock market will act. They're looking for how the stockbrokers believe the market will act, which is a different thing.
But that's only from one company, though.
Correct.
Right?
So if the target population is all stockbrokers in all companies, then clearly this sample, which is the 500 in this company, is not appropriate. Everybody agree with that? Okay. But let's take a look at it again. It says a company employs 500 stockbrokers. They are all surveyed to find out whether a majority believes the market will go up in the next year. A majority of what?
Stockholders in that company.
Yeah. There are 500 stockbrokers in this company, and they want to find out if a majority of those 500 stockbrokers believe that the market is going to go up. And so they ask all of them whether they believe the market would go up or not, and they're looking for whether that proportion is greater than 0.5 or not. Is that a representative sample?
The whole population.
It's the whole population. It's not even a sample. This is a case where they took a census. What would the distribution of p hat be in this case? P is the proportion in the company that believe the stock market will go up. We've asked every one of them. We're going to calculate a value from that. Our p hat is exactly equal to p, and its variance is 0. Standard deviation is 0, because we've asked everybody in the company. Okay? Because it's a census, we don't even have a sample. And because we don't have a sample, we couldn't even ask. In fact, the fact that we have hypotheses here is kind of nonsense, isn't it? I don't have to ask whether p is equal or greater than 0.5. I have p. I know whether it's greater than or equal to 0.5. Okay? So we just take the number we've got. That's our value.
So so there's no p-value then? Or is p just...
There's no inference here. Inference would be taking a random sample or a representative sample, and from that representative sample inferring something about a larger population. But we're not even coming close to doing that here because we're taking everybody in the population. So there is no inference going on. So there can't be even a p-value.
Because we know the exact value? Is that...
Yes, because
okay.
we know the actual population value. I suppose we could try to work through it as if it were a sample. Problem you're going to run into is usually the standard error or standard deviation ends up in a denominator someplace, and what you're going to end up with here is you should end up with a value which is essentially 0. Now this is a case that actually came up, it was in the 1 o'clock section on Monday where they were asking about if the sample size was close to the true size of the population, what would happen. This is a case where the sample size is equal to the population. In general, when we're doing any kind of work like this, we're assuming that the population size is much, much larger than the sample size. So in that case, we can kind of ignore the relationship of the two. Here, we're actually taking values of the entire population, so we wouldn't even continue in this. Okay? How about D? A market research firm wants to know whether more than 30% of the people who visit a mall actually buy something. A researcher stands by the exit door starting at noon and asks 50 people as they are leaving whether they bought something. Null is p is equal to 0.3, alternative is p is greater than 0.3. So if we take a look at this, we have sample size, we have 0.3 is our p0. So see, we didn't do v, n is equal to 50. P0 is equal to 0.3. That implies that we have 50 times 0.3 and 50 times 0.7. This is the critical one. This is equal to 15. So sample's large enough, right?